Alright, so we're going to take a look at linear regression and using the calculator to help us out with some linear regression. I want to go to, let's see, this example, I think, on this next page, about temperature and cricket chirps that we were actually looking at in the next section, in the previous section as well, and see what we can do to take that a little bit further. So we had already put those values for x and y for temperature and cricket chirps into our list under stat edit. We just entered the data there. And we had already looked to see that there was significant correlation under stat, and then over to tests. The LinRegTTest is down toward the bottom of the list. Again, leave everything the same and go down to calculate. Alright, so we checked that value of R was 0.864 roughly, and that was greater than our critical value that we had from the table of 0.707 for our 8 pairs of data. Okay. So we already checked that we had significant correlation. So that means that there is a meaningful linear relationship between these two variables based on the data that we have at least. So to find that linear relationship or the equation of that line, LinRegTTest actually gives us that information as well. We just have to go up a little bit from what we scrolled down. We originally started at something like this to get the value of A and B for our y equals A plus bx linear model. So we can find A and B there and put them together and get, let me zoom in a little bit maybe, and get y equals negative 182.059 plus 14.801x. That gives us a y-intercept, negative 182.059, and 14.801 is our slope of that line. You notice a positive slope there, 14.8, corresponding to our positive correlation that we found in the previous section and that we see again here. There's a couple things that we can do with that. If you're curious, we can see what that line looks like compared to our scatter plot that we drew. So again, to get that scatter plot, we went to second stat plot, second y equals, and turned on the first plot and made it a scatter plot. And then we did a zoom stat, zoom up in the middle at the top there, and then zoom stat as number 9 on most of the calculators, I think, and we get a scatter plot of that temperature and cricket chirp data. Now if we want to plot that line of best fit on top of it that we found, we can enter it in the regular y equals, not second y equals where we went to stat plots, but in the regular y equals, just hit y equals up at the top left, and we can put in our line, y equals negative 182.059 plus 14.801x, and the x that we want to use is this xt theta n button next to the alpha button. Alright, so that'll get our line, and then if we hit graph, we already had that good window, so we get a nice view of that line going over our scatter plot of those points there. So this is our line of best fit, and again, what this is really doing is minimizing the sum of the squared different distances, vertical distances from these points to that line. So if we had a line with a less steep slope or something like that, evidently it would cause there to be more of a difference on average from of those points. It's the sum of the squared differences that we're trying to minimize there. That's what this regression formula does for us. What the formulas for those coefficients do for us is minimize the sum of the squared differences from the points to that line. So you notice that line doesn't actually go through any of those points exactly, but it does kind of go through that cloud of points. We get a line describing that trend, and it's the best line that we can get to do that based on that least squares regression. Alright, then the next step that we did was to take that regression line and use it to predict a certain value of y given a value of x. So we tried to predict the number of chirps if the temperature was 74 degrees Fahrenheit. So 74 was in our ballpark of those temperatures there. That's the first thing that we had to check. We had temperatures going from 70 up to 93. So 74 was in there. And what we're trying to find is what's the best predicted value of the number of cricket chirps from that. And we did that just by plugging in the value into our regression equation. Let's see, where am I at here? Oh, sorry, wrong page. I did it again. And a little bit more. Alright. And we found a best predicted number of chirps of 913.2. Now the calculator has some nice ways of doing that besides just typing in the equation and plugging it in. You can use the tables actually to help you out a little bit. So if you hit second graph and go to the tables, it'll give you a bunch of values, and you'll get scroll around to find 74. Or we could actually, if you go to where is it? Table settings, second and window to table settings, and have it ask for the independent variable. Then what we can do is go back to that table and put in the value that we want, 74, and it'll find that number of cricket. predicted by our linear regression line. All it's doing is taking that x equals 74 and plugging it into what we had in y1, which was that line. So you can use the table to help you out. It's just as easy, really, to type in and calculate it. So whatever you're comfortable with there, you can try. We can also play around with that graph a little bit that we had and see where this point actually is, what this regression line is actually doing in terms of that prediction. So if you choose trace instead of graph here, the fourth button up at the top, and we can trace along. And oops, I don't want to do that. I will just want the line there. Let me turn off that scatter plot first. I think we need to do that, and then we can do trace. And go back to that graph. All right, there's just the line then, without the points on it. But and then we can do trace, and then find where 74 degrees would be. I'm just looking at the x values there until we get to 74. I'm just hitting the arrow keys to get over there. Let's see, 73.86, 74.15. So right in between those two, we get between 915.5 and 911.23, and our 913 chirps was right in there. So we're right in between those 2 points that we get by tracing along that line on the calculator. And so that's exactly what that prediction is doing, is taking that best line of best fit and finding where the y value is at that given value of x, finding what the best predicted number of chirps is at that given temperature based on that regression line that fit those points best. Again, that line doesn't go through all the points, doesn't go through any of the points exactly for that matter. So we're not guaranteed that would be the exact number of cricket chirps that we get, but on average it'd probably be the number of cricket chirps at that 74 degrees Fahrenheit if that model were to hold up, and we've said that there was significant correlation, so it seems like it would. Okay, so we'll try one more example with making a prediction here. We did one about fuel consumption based on weights of a car, and went with that. You can go through that example again if you want with a calculator and see how that goes. But let's take a look at this one, finding the best predicted height for a daughter whose mother is 66 inches tall. All right, so let's enter that data for mothers and daughters' heights in inches into the calculator, and I'll do that real quick and probably pause the recording to save some time here so you don't have to watch me just typing. Alright, so by the magic of pausing the video there, we've got the data in the calculator under Stat Edit, and then we'll go to LinRegTTest. The very first thing we need to do before we make that prediction, well, first we'd want to check that the x value that we're predicting on is in the range of values that we're given, and it is 66 was right along with the mother's heights that we were given. And now we want to check that we have significant correlation. Alright, so again, Stat, over to Tests, and then LinRegTTest. And everything's in L1 and L2 again, so we can just go all the way down to Calculate. And before we can use that A and that B, before we can use the regression equation, we have to go down and check for that significant correlation. And we got 0.693 this time for our correlation coefficient, R, and that was not significant, not greater than 0.707, which was our critical value that we had for n equals 8, for our 8 pairs of data. So we had to beat 0.707, and we didn't do it with this example. So we don't have significant correlation there. So then our best predicted value of y can't come from that regression equation. That regression equation, y equals a plus b times x, is meaningless. Even though the calculator will calculate it for you, it doesn't mean anything if that correlation is not significant. We're trying to force a line then where there shouldn't be one. Force a linear relationship where we're saying that there's not a linear relationship. So our best prediction then is just to average the y values that we had, average the daughter's heights that we had. Again, regardless of what the mother's height would be, that would be our prediction, the average daughter's height. And the calculator is a nice way of computing that average. If we don't want to type it all in again, we can go to 1var stats, stat, over to calc, and then 1var stats. Let me not do that twice, stat, calc, 1var stats. And choose the list that we want to take the average of, or that we want statistics of, and that's list 2 in this case, the y values that we had, those daughter's heights that we put in. So we'll hit enter on that, and it gives us our x bar there. Really it's our y bar, because our y's were those daughter's heights, but the average of that list is 63.3 inches, and that's our best prediction in that case, since our regression equation would be meaningless. Not meaningless, but not significant, because our correlation wasn't significant. Again, that 1var stats gives you all kinds of other stuff too, but in particular that's what we're looking for this time.